Now let's do another example using the same reaction as in the previous lecture video. The equilibrium constant is still 0.11 for the reaction where 2 moles of iodine monochloride decompose to form 1 mole of iodine gas and 1 mole of chlorine gas. Can we calculate the equilibrium concentrations for all 3 species in this reaction? If we start with only products, 0.1 molar iodine and 0.2 molar chlorine. So we're starting with only products and we're trying to see what the concentrations are for all of the species at equilibrium. So for this problem, once again, it's appropriate to use an ICE table to organize the information that we have. So I'm going to rewrite the reaction and make an ICE table underneath it so we can organize the concentrations that we're starting with, which are just initial concentrations of iodine and chlorine, and no reactant at all. So using this bit of information along with the expression for the equilibrium constant K, can we figure out what all the equilibrium concentrations are for the species in this reaction? Okay, so we know that K is equal to 0.11. An expression for K is going to be equal to the concentration of iodine times the concentration of chlorine over the concentration of iodine monochloride squared. Okay, and that comes from the stoichiometry of the reaction. Now, we are going to be losing some amount of iodine and the same amount of chlorine since those are in a 1-to-1 ratio. So the equilibrium concentrations of those are going to be 0.10 minus x and 0.20 minus x respectively. Now, on the other side, we're going to be gaining iodine monochloride. And for every 1 mole of the products that we lose, we're going to be gaining 2 moles of reactant because of the stoichiometric ratio. So the equilibrium concentration of ICl can be expressed as 2x. So we can take these expressions that we just derived for the equilibrium concentrations and plug them into our formula for K. So the expression becomes 0.11, the K value is going to be equal to 0.10 minus x times 0.20 minus x. Those are the iodine and chlorine concentrations over 2x squared, because 2x is the equilibrium concentration of iodine monochloride. So now we know we don't have a perfect square. This isn't as simple as the example in the previous lecture because we don't have a perfect square. What we need to do is simplify this, and it looks like we're probably going to have to use the quadratic formula to solve it. So we need to distribute the terms in the numerator through each other, and that's going to simplify to 0.02 minus 0.3x plus x squared over 4x squared. So what you want to do is collect all of the terms on one side. So you're going to get 0.44x squared is going to be equal to 0.02 minus 0.3x plus x squared. You want to collect all the terms on one side and set it equal to 0, and then use the quadratic formula to solve it. Okay. Now you can use a quadratic solver if you want. I don't care how you solve the quadratic formula. But once you use the quadratic formula to solve, after you simplify this, you should get 2 roots. So in this particular case, x can be equal to 0.46 or 0.078. Now, in this case, one of the answers is going to make sense and one of the answers is not going to make sense. So let's go back and look at our equilibrium concentrations to see which answer makes sense. So here are my equilibrium concentrations for the 3 species in the reaction. And notice 0.10 minus x, 0.46 cannot possibly be our valid value because that would give me a negative equilibrium concentration. So you're always going to be able to throw out one of the roots and identify an x that makes sense based on your equilibrium concentrations. So taking that last row from the ICE table, here we go, I can see that the iodine monochloride concentration at equilibrium is 2x. So ICl is going to be equal to 2x. And that means that it's going to be 2 times 0.078 or 0.156 molar. The iodine concentration is equal to 0.10 minus x, or 0.10 minus 0.078, which gives me a concentration of 0.022 molar for the iodine at equilibrium. And finally, the chlorine concentration is 0.20 minus x, or 0.20 minus 0.078, giving me an equilibrium concentration of 0.122 molar for the chlorine. So this is about as tricky as an equilibrium calculation is going to get for us this semester.